model of the Milky Way galaxy, its billions of stars and swirling nebulae rendered in stunning detail. As you fly through the galaxy, you can zoom in on individual star systems, learn about their planets, and even witness the birth and death of stars. This fusion of VR and real-time data opens up a world of possibilities for education and scientific discovery. Scientists can use VR to visualize complex datasets, identify patterns, and make new discoveries that would be impossible using traditional. Have you ever dreamed of being an astronaut? The idea of floating in the vast expanse of space, looking down at our beautiful blue planet, and exploring the unknown has fascinated humanity for generations. Imagine training for spacewalks not in a giant pool, but in the vast emptiness of space. Traditional methods like underwater training have been effective, but they can't fully replicate the zero-gravity environment of space. Now picture learning to operate a spacecraft while orbiting the Earth. The precision, the focus, and the real-time decision-making required are immense. Virtual reality, VR technology, brings this experience to life, allowing astronauts to practice these critical skills in a highly realistic setting. This is the incredible potential of virtual reality, VR, for astronaut training. VR immerses trainees in a 360-degree environment, providing a level of detail and realism that traditional methods simply can't match. VR is revolutionizing how we prepare humans for space travel, offering a safe, effective, and incredibly realistic training environment. It allows astronauts to practice complex maneuvers and emergency procedures without the risks associated with real-life training. VR allows astronauts to experience the challenges of spaceflight in a controlled and repeatable setting. They can simulate various scenarios, from routine operations to unexpected emergencies, ensuring they are well prepared for any situation. This preparation is crucial for the mental and physical demands of their missions. The psychological stress of space travel can be immense, and VR helps astronauts build the resilience needed to cope with long-duration missions. It's a game-changer for space exploration, making training more effective and accessible than ever before. With VR, we can train more astronauts more efficiently and at a lower cost, paving the way for the next generation of space explorers. As we look to the future, the role of VR in astronaut training will only continue to grow. It's an exciting time for space exploration, and VR is at the forefront of this new era, helping us take giant leaps in training and beyond. Becoming an astronaut requires years of rigorous training. Traditionally, this involves simulations, classroom learning, and specialized facilities like underwater environments to mimic weightlessness. While these methods have served us well, they have limitations. Simulations can never fully replicate the feeling of being in space, and underwater training, while helpful, is physically demanding and time-consuming. Furthermore, some space environments, like the lunar surface, are impossible to replicate on Earth accurately. This is where VR comes in, offering a powerful solution to these challenges. VR technology creates immersive, interactive, three-dimensional environments that simulate real-world scenarios. In astronaut training, this means experiencing everything from spacewalks to docking procedures to the lunar surface, all from the safety of Earth. Astronauts wear headsets that track their movements and display realistic visuals and sounds, making them feel like they are genuinely in space. They can use hand controllers to interact with virtual objects, practicing tasks and procedures in a safe and controlled environment. VR allows astronauts to make mistakes and learn from them without real-world consequences, leading to greater confidence and competence. One of the most significant advantages of VR is its ability to create a sense of presence or immersion. When astronauts feel physically and mentally present in the virtual environment, their brains and bodies react as if it were real. This immersive quality of VR is crucial for training astronauts to deal with the psychological challenges of spaceflight, such as isolation, confinement, and high-stress situations. By repeatedly experiencing and adapting to these challenges in a virtual setting, astronauts can develop coping mechanisms and build resilience, leading to better performance and well-being during actual missions. Section 5, VR versus traditional training, a comparison. VR offers several advantages over traditional astronaut training methods. These advantages span across various aspects such as cost, safety, and the quality of training. Firstly, VR is highly cost-effective. Traditional training methods often require expensive physical setups in specialized facilities. Simulating space environments using physical mock-ups and specialized facilities is expensive, while VR environments can be created and modified digitally at a fraction of the cost. This means that space agencies can save significant amounts of money, which can be redirected towards other critical areas of space exploration. Secondly, VR is safer. Traditional training methods sometimes involve inherent risks, such as underwater training accidents. These methods, while effective, can expose astronauts to potential physical harm. VR eliminates these risks, allowing astronauts to push their limits without fear of physical harm. Training in a controlled virtual environment ensures that astronauts can focus on mastering their tasks without the added stress of potential injuries. Finally, VR provides real-time feedback and allows for repetition and mastery. This immediate feedback is crucial for astronauts to understand their performance and make necessary adjustments on the spot. Astronauts can review their performance, identify areas for improvement, and repeat training scenarios until they achieve proficiency. This iterative process ensures that they are well prepared for the actual mission. This personalized and iterative learning process is highly effective in building skills and confidence. By allowing astronauts to repeatedly practice and perfect their techniques, VR training ensures that they are mission-ready and confident in their abilities. The combination of cost-effectiveness, safety, and high-quality training makes VR an invaluable tool in modern astronaut training programs. Section 6: VR in Action Real-World Examples. NASA has been at the forefront of using VR in astronaut training. Their Project Sidekick program uses Microsoft's HoloLens to provide astronauts on the International Space Station with real-time guidance and support from ground crews. The European Space Agency has developed a VR training system called VRX, which allows astronauts to practice tasks like operating robotic arms and navigating the ISS. These examples demonstrate the practical applications and benefits of VR in current astronaut training programs. Section 7: Beyond Training, VR and Space Exploration. The applications of VR extend beyond astronaut training. VR can be used to design and test spacecraft, plan missions, and even explore celestial bodies virtually before sending humans there. For example, scientists and engineers can use VR to explore three-dimensional models of Mars, identifying potential landing sites and planning rover traverses. This virtual exploration can help optimize mission planning and reduce risks. Section 8: A Global Phenomenon, VR in Other Space Agencies. The use of VR is not limited to NASA and ESA. Space agencies worldwide are increasingly incorporating VR into their training programs. For instance, the China National Space Administration uses VR to train astronauts for their Tiangong space station, while the Japan Aerospace Exploration Agency uses VR to simulate lunar surface operations. This global adoption of VR highlights its growing importance in preparing humans for the challenges of space exploration. Imagine yourself transported to another world, a world where the boundaries of reality blur, and the impossible becomes possible. You feel the weightlessness of space, as if gravity has released its hold on you. Your body floats effortlessly, and you experience a sensation unlike any other. The sun's heat on your visor is almost tangible. You can see the brilliant light reflecting off your helmet, casting a warm glow that contrasts with the cold vacuum of space. You see the Earth, a blue marble in the distance. Its beauty is breathtaking, a fragile oasis in the vastness of the cosmos. The sight fills you with awe and a profound sense of connection to our home planet. This is the power of virtual reality, and it's revolutionizing how we train to explore the cosmos. With VR, we can simulate the experience of space travel with incredible accuracy. VR allows us to experience the wonders and dangers of space without leaving our planet. We can practice maneuvers, conduct experiments, and prepare for emergencies in a safe and controlled environment. VR is more than just a game, it's a powerful tool. It provides a level of immersion and realism that traditional training methods can't match. It's used by organizations like NASA and private space companies to prepare astronauts for the challenges of space travel. These simulations help astronauts build the skills and confidence they need to succeed in their missions. VR bridges the gap between imagination and reality, offering a glimpse into the extraordinary. It allows us to dream bigger, reach further, and explore the unknown with a sense of wonder and possibility. As technology continues to advance, the potential of VR in space exploration will only grow. We are on the cusp of a new era, where virtual reality will play a crucial role in our journey to the stars. So, strap on your VR headset and get ready to embark on an adventure like no other. The universe is waiting, and with virtual reality, the stars are within our reach. Space training is rigorous and demanding. Astronauts spend years preparing for missions, studying complex systems and practicing procedures. VR enhances this training, providing a safe and controlled environment to learn and make mistakes. It allows astronauts to repeatedly practice tasks until they become second nature, building confidence and competence. VR simulates the disorientation of zero gravity, the challenges of spacewalks, and the intricacies of spacecraft operation. This immersive experience allows astronauts to familiarize themselves with equipment and procedures, reducing risks during actual missions. One of VR's most significant advantages is its ability to recreate conditions impossible to simulate on Earth. This technology has revolutionized astronaut training, providing a safe and controlled environment to prepare for the rigors of space travel. By immersing astronauts in a virtual space environment, they can experience the sensations and challenges they will face once they leave our planet. Weightlessness, for example, is a crucial aspect of space travel, affecting everything from movement to bodily functions. In the absence of gravity, astronauts must learn to navigate and perform tasks in a completely different way. VR simulations allow them to practice these skills repeatedly, ensuring they are well prepared for the real experience. This training helps them understand how their bodies will react and adapt to the zero-gravity environment. VR allows astronauts to acclimate to this unique environment, reducing the initial disorientation and discomfort. By experiencing weightlessness in a virtual setting, they can gradually get used to the sensation, making the transition smoother when they actually enter space. This acclimatization is crucial for maintaining their efficiency and safety during missions. VR also simulates the psychological challenges of space travel. The mental strain of being in space for extended periods can be significant. Astronauts must cope with isolation, confinement, and the vast distance from Earth. These factors can lead to stress, anxiety, and other psychological issues if not properly managed. The isolation, confinement, and distance from Earth can take a toll on astronauts' mental well-being. VR training helps them prepare for these challenges by simulating the conditions they will face. They can practice strategies for managing stress, staying focused, and maintaining their mental health. This preparation is essential for ensuring they can perform their duties effectively and safely. VR exposes astronauts to these stressors in a controlled environment, allowing them to develop coping mechanisms and build resilience. By facing these challenges in a virtual setting, they can learn how to handle them before they become a reality. This training not only prepares them for the physical demands of space travel, but also equips them with the mental tools they need to thrive in the harsh environment of space. The combination of physical and psychological preparation through VR is transforming how astronauts train for their missions, making space travel safer and more efficient. NASA's VR lab is at the forefront of this revolution. This cutting-edge facility is transforming the way astronauts prepare for their missions, offering an unprecedented level of immersion and realism. The lab employs state-of-the-art VR technology to create highly realistic simulations of space environments and missions. These simulations allow astronauts to practice spacewalks, dock with the International Space Station, and even perform complex docking maneuvers with the ISS. This hands-on experience is crucial for ensuring mission success. The VR lab also enables astronauts to explore the lunar surface, simulating the unique challenges and conditions they will face on the moon. This includes navigating the rugged terrain and conducting scientific experiments. All of these activities take place within the confines of the lab, providing a safe and controlled environment for training. The VR simulations are meticulously designed to replicate the actual conditions of space. These simulations are not just visually impressive but also incorporate realistic physics and environmental factors. This means that astronauts can experience the true dynamics of space, from microgravity to the harsh vacuum. Astronauts feel the resistance of spacesuits, the weight of tools, and the subtle movements required for precise maneuvers. This physical feedback is essential for developing the muscle memory needed for real missions. The VR lab allows astronauts to practice precise maneuvers, such as handling delicate instruments and performing intricate repairs. This level of detail ensures that they are fully prepared for any task they may encounter in space. This level of realism is invaluable for preparing astronauts for the unexpected. By training in a highly realistic virtual environment, astronauts can develop the skills and confidence needed to handle any situation that arises during their missions. The VR lab is truly revolutionizing space training, providing astronauts with the tools they need to succeed in the final frontier. Section 5. Shaping spacecraft from the inside out. Virtual reality's impact extends beyond astronaut training. It's influencing the design of spacecraft themselves. Engineers use VR to create virtual mock-ups of spacecraft interiors, allowing them to test ergonomics, optimize layouts, and identify potential issues before physical construction begins. This virtual prototyping helps reduce development costs, shorten lead times, and improve the overall design and functionality of spacecraft. By experiencing spacecraft in the virtual realm, engineers can ensure that they are comfortable, efficient, and safe for their human occupants. Section 6. Beyond the Stars. VR's expanding universe. The applications of VR extend far beyond space exploration. Its immersive and interactive nature makes it a valuable tool in various fields, including medicine, education, and even the military. Surgeons use VR to practice complex procedures, students explore ancient civilizations, and soldiers train for combat scenarios, all without physical risks. This cross-pollination of ideas and technologies is accelerating the development of VR, leading to more sophisticated hardware, more realistic software, and a wider range of applications. Section 7. The future of space training, a new horizon. As VR technology continues to advance, its role in space training and exploration will only become more significant. We can expect to see even more realistic simulations, incorporating artificial intelligence, haptic feedback, and other sensory inputs to create truly immersive experiences. Imagine astronauts training for missions to Mars by exploring virtual replicas of the Martian surface, interacting with virtual representations of Martian life, and even feeling the Martian wind on their skin. The possibilities are as vast as space itself. Section 8. Igniting the imagination. VR's public appeal. VR also has the power to inspire the next generation of explorers. By making space exploration more accessible and engaging, VR can spark curiosity and ignite a passion for science, technology, engineering, and mathematics fields. Imagine classrooms where students can take virtual field trips to the moon, explore the rings of Saturn, or even journey to distant galaxies. VR has the potential to revolutionize education, making learning more immersive, interactive, and fun. Section 9. A universe of possibilities. VR's enduring legacy. VR is not just a technological marvel, it's a testament to human ingenuity and our unyielding desire to explore the unknown. It allows us to push the boundaries of what's possible, to experience the awe-inspiring wonders of the cosmos, and to prepare for the challenges and triumphs of space exploration.